this is a very different talk than the one we saw before. I guess I'll start by introducing myself. I know a lot of you from avatars on Slack. I know some of you in real life. So who am I? I'm actually not a DevOps engineer. I'm the founder and CEO, one of the founders and the CEO of Bastion Zero, which is a local company that builds software for securing infrastructure access. My story is I've been in tech for over 20 years. I started out as a telecom engineer. I actually used to work at a power company. I went and did a PhD, and I focused on cryptography and information security. After my PhD, I got a job at BU here in Boston, where I teach InfoSec and network security. Also ran a research lab for a long time. Most of my work at the university, sort of like the product, went into the internet engineering IETF. What does that stand for? I can't remember anymore. Anyway, so I used to work with the IETF a lot. I still work with an IETF. I actually had one of my RFCs just came out after 10 years in August. It was RFC 9384. Yeah, I know, 10 years. Thank you. After doing that for a while, I wanted to move into something more fast-paced, and so I founded Bastion Zero. It did take 10 years. I'm not even joking about that. What we do at Bastion Zero is our product provides simple, passwordless access to back-end infrastructure, things like servers, databases, containers, clusters. We do access, not just granting the access, but also the authentication, the authorization, also known as policy, so who has access to what, at what time, just-in-time access, all of those things. We do that for databases, and we also have a big logging component, which is just to say that you can track like who logged into what they did. We have command logging, session logging, and all the types of things that you would need to comply with auditing requirements and security and forensics. So that's what my company does. I actually still teach at BU. Tomorrow morning I'll be teaching InfoSec, Intro to InfoSec at 8 a.m. at BU. That's my LinkedIn. I used to use Twitter. I don't use it anymore very much. So if you want to find me, I'm actually pretty active on LinkedIn. So if we haven't met here, reach out to me on LinkedIn, and I'm very online. So it would be great to chat even if we can't chat in person. Okay, so where did this come from? January 4th, 10 p.m., I was checking Twitter before going to bed, and I was like, whoa, what is this? So how many people remember had to deal with CircleCI breach? Yeah. So I was pretty shocked at the CircleCI breach because CICD pipelines are so sensitive, right? So a CICD pipeline will store access credentials for, I'm sorry, I'm really struggling with the light. Maybe if I stand here. That's actually better. Okay, so CICD, is really sensitive because it stores credentials, API credentials, SSH keys, all sorts of tokens and things that are really important for access to your infrastructure, obviously, because what is a CI/CD pipeline doing? It's going in and it's programming your infrastructure for you, right? It's an automated way of programming infrastructure. So it needs a way to program infrastructure. So just from 1,000 feet, if an adversary controls the tooling that you use to program your infrastructure, they can program your infrastructure to do bad things. Very big problem, right? So really fundamental problem in DevOps, and I know that everyone in the world in this room thinks about it in one form or another. There's a lot of different components to my talk, but I just want to give you a couple of things that we've thought of at Bastion Zero and looking around in the industry that you can look to do to improve the security of your pipeline. Some of them are easier to do, some of them are harder to do, but I'll just give you sort of a spectrum of different things that we've thought about at Bastion Zero. Okay. So this is what happened on January 4th, and this really struck me. Thank you for your urgent attention to rotating your secrets, right? So it was 10 p.m., and it was like people were just staying up all night rotating secrets. So what actually happened? So what is CircleCI? It's a SaaS service. The SaaS service was where the breach happened. The way the SaaS service worked was that you would give the SaaS service your credentials, and then what you would do is whenever you needed to do something, you would spin up a runner, you would give the runner the credentials that it needed to actually take the action that you wanted it to take, and then it would program your infrastructure in the appropriate way that you had told it to do that. And that means that the SaaS service actually had all the credentials that it needed to have in order to spin up these runners to access your infrastructure. And so what happened was a database compromise at CircleCI, all the credentials were breached. And in fact, the understanding was that all of the credentials were breached. And so thank you for your urgent attention to rotating your secrets. All of these credentials had to be rotated. And I spoke to various teams. Some people were able to do it in a week. Some people spent a month, 6 weeks. I know companies that kind of dropped whatever they were working on and focused specifically on CICD security right after this happened because they realized this was a very tangled web. CICD is extremely complicated, and people really tried to improve this after this happened. So if you haven't been through this exercise yet, I'll give you a couple of things to think about. And I think this is my easiest one. I spoke to a friend who told me he spent 2 weeks rotating a single credential because that credential was used in so many other systems, and he had to get in touch with lots of different teams get all those teams to rotate their use of their credentials, because if he didn't do that, everything would break, right? So one thing that's pretty clear that you can do is if you look at your credentials that you're putting into your pipeline, if there's a way to use a fresh credential for the pipeline and a different credential in other places, that could be really helpful, because if you ever are dealing with a CI/CD compromise, a simple thing you can do is just rotate the secret that's in the CI/CD pipeline but it's not touched by anyone else for any other purpose. You're going to save yourself a lot of pain, and you can do the rotation faster. So if there's anything that's like really, really low-hanging fruit, a lot of times with a service you can get multiple API keys to do the same thing. Get one special for the CI/CD pipeline, use it there, okay? And just don't use it anywhere else. That'll just easy, small thing that will help make your life a little bit easier. Okay, so that's my first, and I put that first just because I think it's the simplest. I could be wrong, but I think this is the simplest. Okay, so after the CircleCI breach, I think there was the inevitable conversation about don't use CircleCI, it's a SaaS service, don't give your credentials to a third-party SaaS. How many people had that reaction? I'm just curious, is that a reasonable reaction? Yeah. So I think it depends on where you are in the world and your background. So I have another talk that I submitted here that you guys didn't accept, which was to self-host or not to self-host, and I presented the arguments of self-hosted things versus SaaS-hosted things and which one is better. So I feel like people have different opinions on this. I just want to say that I strongly believe that self-hosted versus not self-hosted is not the issue here. I think CI/CD is fundamentally an issue for security, and you self-host it, you're not going to solve all your problems. You can do other things to kind of again, limit the blast radius of these attacks if you use, the kinds of security groups, ACLs, IAM policies. If you really try to limit what pieces of your infrastructure can touch these credentials and actually use that, I feel like that's going to be a more effective way to limit blast radius than just say, oh, I self-hosted it, it's okay. Even though in the case of CircleCI, the SaaS was the thing that was breached. I just want to point out that we are all very familiar with different kinds of CI/CD tools, and we all know about Jenkins, right? So this is a list of the CVE records of Jenkins that I pulled at the beginning of this year. So we have over 1,000, so 1,400 CVEs in Jenkins, right? So if you're going to self-host something like a Jenkins pipeline, you have to be really careful to make sure that it's actually up to date, right? Because the CVEs are being found frequently. So you don't want to be hosting a Jenkins pipeline, which is self-hosted, that's full of vulnerabilities. If you actually look at, I think I have some, I'll share these links with you after. There's a really cool blog by the NCC group where they do, I think, 7 or 10 different exercises that they did, pen testing exercises, penetration testing exercises on CI/CD pipelines. And a lot of them were on Jenkins, and really they're going after Jenkins because that's where the secrets are. So once you're in the Jenkins box, you can pull a lot of secrets, right? So that is a big issue. And it's also an issue because if you're managing it yourself, you really need to be careful that you're not running a version of Jenkins that's unpatched, right? You don't want to be in that situation. Just another thing about Jenkins and the fact that things are self-hosted versus not self-hosted not being the issue. This was a story from the NCC group that I just pulled because I thought it was interesting. They had found a pipeline where the administrator had granted read permissions to all authenticated users, and then this used GitHub repository permissions. What that ended up doing was anyone who had a GitHub account was considered an authenticated user. Therefore, anyone who had a GitHub account could log into the CI/CD pipeline, which is not what we want, because every developer in the world has a GitHub account, right? So it was basically completely open, and it was because the permissions were confusing. So just as an example of like, this can be very tricky, and you need to be careful, right? So this is like a real example of that. So how do I give you some framework to work under? I'm a big fan of the NIST 82207 Zero Trust definition. It is a really long document, but there's like a 2-page section in there. And I know you're maybe tired of hearing the word zero trust, but I'm talking about the actual like sort of scientific or standards body definition that NIST gave us. I really think it's worth, by the way, if you're in this room, like go read them. It's just good to know. It's just good to like internalize, because the principles there are really sensible. And you can apply them to lots of different situations. So what I tried to do with this talk was to pull some of the items from the definition and just apply them to CI/CD. So if you want to take a picture of this slide, this is kind of a bit of a summary. So, first thing is that network location alone does not imply trust. Just the fact that you've self-hosted something doesn't mean that you're secure, right? And this is straight out of the NIST concept of zero trust, which is that the position of your service doesn't necessarily mean that it's secure. You need to authenticate. You need to make sure that everyone's authenticated to the service every time they access it, and not just kind of wash your hands and say things are behind a VPN, or things are hosted by me and therefore they're secure. I think we're way past that era in security, and as you all know, right? Another thing from the NIST Zero Trust principle, I'm looking at number 3, access should be granted with the least privileges needed. So what does that mean in the context of a CI/CD pipeline? So one of the things, right, that's interesting about a CI/CD pipeline is that when you have a runner and you have a number of people that have access to that runner, there are all the secrets that are in that runner are then potentially accessible to all the people who can run that process or access that runner. Right? So this is kind of hard to think about, right? But the thing to think about here is who can touch this runner, who can get in here, and what secrets are stored, right? So again, we're falling into this traditional like zero trust idea and DevOps idea of segmentation, right? You have a runner, only certain people can access it. There are certain secrets in there. Who can reach this runner, and therefore what secrets do they have access to, right? That's one of the things to think about when you're kind of auditing the security of your pipeline. So another way to look at that, right, is like there are all these people that can log into the runner. Which users can log into this specific runners? Which secrets are particularly in this runner? Who can commit to this pipeline? Who cannot commit to that pipeline? Trying to get sort of the permissions sorted out for this is another thing you can do to make the pipeline safer. If you don't have a good picture of what this even is, then that's a great place to start and have an audit and look through and see what you're doing, right? So I don't know how many people feel like they really fully understand this. Maybe you don't, so that may be something to look at, because you don't want an adversary to be able to get in through one of your users into the pipeline. Another thing in terms of number 3 here, access should be granted with least privileges needed. This is a little bit from the Bastion Zero's perspective, but it is again a general principle. Scope the pipeline access to the infrastructure. So if you have a process, right, and it needs to do something, if you have a runner that needs to do something, you want to make sure that that runner doesn't have access to maybe your entire cloud and all your accounts. You want to restrict it to the accounts it should have access to, or the parts of the accounts that it should have access to. So trying to understand for a given runner, a given process, what it has access to, and whether it should have access to those things, that's another place where you can tighten things up. One of the things that we've done in Bastion Zero, as I mentioned at the beginning, it controls access to infrastructure for users, but we also have features around service accounts. So if your pipeline needs to get access to your infrastructure, if you ran it through our service, one of the things that we do is you can have policies to grant least privilege access. So this service account can only access this particular server as this particular user. The idea of time gating this access, again, you can do this with our tool, you can do it in other ways. The service account should only be running at midnight, right? We only run processes at midnight, so turn it off the rest of the time. The other thing that we've done at Bastion Zero, which I can talk to you about separately, is we've added this sort of MFA concept where our system will actually not allow the service account or the runner to touch the infrastructure unless there's been a GitHub action that actually initiated the deploy. And so we have an integration with GitHub action that effectively turns off the service account if the GitHub action wasn't run for this runner. Okay, so the runner doesn't have access to anything, which means if you hack into the runner, you steal the credential for the service account, you can't still access anything unless you can also compromise this piece, GitHub actions. So And the final thing is, again, from a forensics perspective, when you're looking at CICD, the same way you want to log your user's activity, you want to log your pipeline's activity. So where are your logs? How are you logging? What are you doing with those logs? Do you even have logs, and are you storing them somewhere where you may be able to use them if you need to debug something or figure out how you were breached? Okay. Great. Okay, so now how many people have heard about OpenID Connect as a way of sort of like securing CICD? So I'm going to do a little bit, as I told you, I'm a professor, so I'm going to teach you a little bit about OpenID Connect now so you can kind of understand what this means. This is my gift to you. Quick lesson on OpenID Connect and how it works. It's kind of confusing, so it's actually simple once I draw it for you, but try reading the docs and then it's not as fun. Okay, so there are certain, so OpenID Connect is a protocol that you can use for single sign-on. We all know what single sign-on is, right? Identity providers provide single sign-on. We as humans can use single sign-on, but workloads and machines can also use single sign-on. It's a lot more annoying to think about single sign-on in the context of workloads and machines, but one of the patterns that you find, for example, with GitHub Actions when it's acting as an identity provider, is the following pattern, okay? As a user, by the way, what I do is I put in my username and password, I get an OpenID Connect token back, and I serve that token to, like, let's say I want to log into Zoom using my Boston University credentials. I could provide my OpenID Connect token to Zoom, and then now I can log in as a Boston University person on Zoom. Okay, so with a workload, this is how it works. What happens is these workloads will spin up. They will have, as part of their spin-up process, an API key and secret. They will interact with the identity provider. That will authenticate them because the identity provider kind of knows that this is a box that's spun up that is allowed to, this is a process that's spun up that's allowed to authenticate to me. So it spins up, it connects to the identity provider. The identity provider gives an OpenID Connect token. That's what happens here. Okay, so you spin up, you authenticate with the credentials you get as part of the process being spun up. This identity provider knows that these credentials are valid because it's in the set of credentials that could be issued and used to authenticate here. Now you have the OpenID Connect token. Now what happens, let's say you want to log into your AWS account, you log into the STS, Secure Token Swap API, using the OpenID Connect token. This API knows that this is your identity provider for this account. So you have an account here. This thing is configured to know it needs to trust this identity provider. So now you have the OpenID Connect token. This guy has validated it. Now what it does is it gives you temporary credentials for AWS that you can now use in the AWS API and do things to the API. Okay? So what you've just done here is you've had this process that's basically known to the identity provider, right? It spins up with these credentials. It allows it to get an OpenID Connect token. From there, it interacts with the AWS API to get the temporary credential that you can use to do like normal stuff on AWS, right? And that's how this all works. So this is really nice because instead of giving your processes like an API key, do you see how there's no API key stored here? Isn't that nice, right? It just spun up and it's known to the identity provider. So you have much less credentials to manage if you use this approach. That's why this is cool, okay? So that's my, my little professor lesson for you. Okay, so bottom line, AWS account is configured to trust the OpenID provider. They don't need any credentials. The OpenID provider is the thing that needs to only have credentials, and the only relationship is the one between the OpenID Connect provider here and the API here, right? This is configured to trust this. The blue is configured to trust the yellow, and that is all you need to have this whole process work. It's because the identity provider knows that these are workloads that are authenticated to it. So you have a subsystem that's doing that on the side of the pipeline. Okay. Cool, so just I still have more time and there's another thing I want to talk about. So this is what I want to wrap up in terms of like CI/CD pipeline security. The easiest thing, right, limit reuse of long-lived credentials. This, by the way, does not map to the zero trust framework of NIST because NIST framework hates long-lived credentials. It's like do not have any at all, which I think is great, but realistically you may not be able to do that in real life. So in real life, since you cannot get rid of every long-lived credential, make sure that the long-lived credentials you use are specific to that pipeline and make a copy, get a fresh credential from whatever it is and put it in your pipeline, okay? 2, scope user access to the pipeline. Make sure the right users have access to the right runners. Scope the pipeline's access to the infrastructure. Make sure the runner has access to the right subset of what it's touching in the infrastructure. Logging, do you have logs? Where they're being stored? Can you retrieve them? Limit use of long-lived credentials when you can with OIDC. So again, it's much better to use OIDC than to have a long-lived AWS API credential, for example, in your runner, okay? Which is what I showed. I think the thing that I forgot to mention, right? Again, when you have these, this process, it's not all so trivial and easy, because if you don't make sure that the runner is scoped, right? So when you do this process, what I forgot to mention, I apologize, is that the runner needs to be only touching the parts of the AWS API that it should be touching, right? It would be terrible if all your runners would spin up with sort of full access to the entire AWS API, right? So when you do this, you need to actually figure out how to make the OIDC token scoped properly to do the things it needs to be doing. This is where the difficulty comes in actually implementing this, right? But that's what you're looking to do. Okay, so for this particular runner, it needs these permissions. Make sure you're scoping the OIDC tokens to those permissions. That part is a lot trickier. Okay, now I want to say, right, so make sure your OIDC tokens are properly scoped. Okay, so now I want to say something else. In the time between when I submitted this talk and the ensuing several months, something very cool happened at Bastion Zero that I want to tell you about, and it's very relevant to CICD security, and it has to do with what's being currently called supply chain security, or provenance, right? So far I've been talking a lot about like, what are the credentials that are in your pipeline? Where do they come from? How are you storing them? And how can you either limit the blast rate? Basically, I've been talking about limiting blast radius for this entire talk, right? If something gets compromised, how can we quickly rotate or make sure that it's only scoped to like a very small piece of our infrastructure, not sort of a full-scale compromise of everything? Another thing to think about is like, what are you actually deploying, right? When you're deploying images, are these secure images or are these malicious images? Have you gotten them from a secure place? Is there code provenance? Is there provenance of the images themselves? And that's another thing that we've been recently sort of happened organically at Bastion Zero that I wanted to tell you about. So secure provenance, an example of secure provenance is, for example, if you have a code repository, you have a bunch of developers and they're all contributing to the code repository. I think most people have heard of these attacks where they actually had malicious commits to the code base, right? Where there was an adversary maliciously committing and changing the code base, and therefore things were getting deployed in the field that were actually malware out of the legitimate repo, right? Because there wasn't good provenance of like what developer made what change to the code. That's another thing to think about. And I think it affects this whole, maybe a little more peripheral, but it still affects this whole problem of like making sure that what we're deploying is actually secure and correct and not malware, right? So if the code repo has been compromised, then you have an issue. Another thing is, again, if you've got like images, if you're pulling, I'm using the example of Docker because we're actually collaborating now with Docker. If you're pulling images, let's say from Docker Hub, and those images are not trusted, those images have been put there by an adversary, then you could be deploying Docker images that are malicious, right? So this whole idea of like, how do you make sure you know the provenance of what it is that you're deploying in your infrastructure, the software supply chain security, I wanted to just briefly take like a few minutes to just talk about one of the cool things that we're doing in Bastion Zero. It happened 2 weeks ago. That's my co-founder, Ethan Heilman. He's on the stage at DockerCon. He's actually announced that our open sourcing part of what we developed at Bastion Zero. So I didn't really get into this too much, but what's happening is that we've, for many years, for 3 years, we've had this very unique way of interacting with OpenID Connect that was built into our product. I haven't explained any of this to you or why it's there, but we had it and we've been using it for about 3 years, and then we recently kind of pulled that component of our tool out, we wrote it up, and people got interested in it, so we decided to open source it under the Linux Foundation, and that was announced less than 2 weeks ago, so about 10 days ago we announced that, with a collaboration with Docker. And what Docker is actually going to be doing is using OpenPubKey for signing their Docker official images, okay? So what I want to do is just take like a few minutes just to tell you about OpenPubKey. We're very excited about it here. It may be useful to you, it may be useful to your organization, and I just wanted to bring it up in case it's something that you might want to collaborate with us on. So what is OpenPubKey doing? OpenPubKey is just solving a very fundamental problem in cryptography, which is certifying public keys. So for example, if you have like a container image that's signed by Alice, right? How do you know that this signature was really produced by Alice? How do you know that this container was really generated by Alice and signed by Alice? How do you know that a workload was really spawned by Alice? How do you know that a code commit was really committed by Alice and not by someone pretending to be Alice, right? The problem of making sure that someone who signed something is actually the person who did the thing, that's called public key certification. So here's my public key, and this is really my public key, and not someone pretending to be me, right? That's the problem that we're solving. Why is this a big problem, right? If you have someone pretending to be Alice but using their own key, right? They can sign something and make it look like it was signed by Alice even though an adversary signed it, right? That is basically a complete breakdown of cryptography. Cryptography is worth nothing if this happens. So this is, again, the problem of certifying public keys, making sure that this is Alice and this is really Alice's key. If you don't have that, you have no security for anything. And this is what traditionally in security was solved using certificate authorities. So what is a certificate? It's the little thingy at the bottom, the square. It just says that, here's the person, here's their key, and then we have some trusted party known as a certificate authority that's saying, yes, this is really Alice, this is really her key. I checked all of this using my special magical certificate authority techniques, and here's a certificate that proves that this key belongs to Alice. Okay? But CAs are actually really, really hard to operate. Has anyone in this DevOps conference ever run a CA? Are they fun? They're not fun. They're not fun because everything you do fails. Like if you make a tiny mistake when you're running a CA, everything will break, right? So they're really, really hard to run in a fault-tolerant way. They're also, they're hard to run, they're hard to secure, and they're also really hard to actually do the authentication to prove that, this is Alice and this is really her key. How do you do that? Do you show your passport? Do you show your state ID? Do you put in a biometric? Do they take a picture of your face? How do you do any of this, right? This is the problem that's sort of fundamental to any certificate authority problem, and this is one of the reasons why we can't really have nice things, right? Because running this is hard, so it's very hard to just have everyone have public keys that we can use to do cool things. However, there's this thing in this world called identity providers, right? Like Okta, Azure AD, all of our identity providers. So what OpenPubKey is, we basically realized that we could use your identity provider as a certificate authority. Effectively, we can use your interaction with something like Okta to certify a public key for you. That's what OpenPubKey does. Okay, so you interact with your, let's say, Okta, and you get a certified public key. And how do we do this? We actually piggybacked on OpenID Connect, which was the thing I showed you before. So we use OpenID Connect interactions, we modify them a little bit, and what we add to the OpenID interaction is we generate this thing called an OpenPubKey token, PK token, which in addition to the usual OpenID Connect stuff, which you can see here in purple, there's also the public key, and it's going to be signed and certified by your identity provider. So now, and the cool thing about this is that we actually did not have to modify OpenID Connect at all. It works with today's OpenID Connect, which means you can use this today with Okta and Azure AD and all these other identity providers to get certified public keys. And so, what Docker is doing with this is they're going to use this approach of interacting with your identity provider to sign Docker official images. So that's really exciting. What we do with it at Bastion Zero is we use it to authenticate users to your identity provider, and then use the public key that they authenticate through OpenPubKey to actually authenticate their connection to servers, containers, clusters, databases. So we use that public key to generate authenticated channels that you can use to access things. Okay, that's what we did with it at Bastion Zero for the last 3 years. Docker is going to be using it for authenticating images. So thank you for allowing me to take that little tangent. I'm very excited about this. We have just open sourced it a couple weeks ago. We have already various people contributing. So if this is interesting to you, I put the link to the repo here. Hopefully this will play a big role in software supply chain security in the next coming set of years. And if you're interested in talking more to me about just sort of the DevOps perspective on CICD security, I'm interested, love to talk to you. If you're interested in talking to me about OpenPubKey and its broad set of use cases as a way of certifying keys using your identity provider, I am here. So thank you very much for giving me this stage, and looking forward to talking to everyone. Thanks. Huh? Yeah.
If anyone has any questions, we can take a couple questions. Oh, I should see if there's any up top. No questions? Thanks.
No, there's one there.
I just have a question. How did you get into this domain, and what made you develop OpenPubKey?
Yeah, so personally, I've been in cryptography since 2005, which is a whole other story. We got into Open PubKey because we wanted to build a way to access infrastructure in a way that our service could not intercept or alter the communications of our customers. So we needed that public key to set up a channel that would run through the system from the engineer's laptop to the server or to the Kubernetes cluster or to the database. We needed that public key to set up that channel. We were like, how do we get a public key that we don't control? And that's with Open PubKey, because the user can interact with their identity provider to get that public key and now use it to communicate through our system. And then we built the whole system on top of that. So we had this really cool way of establishing public keys that we were kind of using for a long time, and then we exposed it. We wrote up a paper, and then we had people coming to us. We were like, what do we do with this? We figured we'd get a lot more development into the tool if we open sourced that piece of the platform. Yeah, so that's how it happened.
Is your question?
So from my experience, every time that you tell a development team, now you should adhere to new securities, I'd never see them start a party, ever. Right? So my question is, in your opinion, what is the sweet spot between adding additional security to allowing productivity, team autonomy, and all that? So I'll give you an example.
Yeah.
GitHub Actions.
Yeah.
Right? Public GitHub Actions, making a lot of developers very productive.
Yeah.
And many of them use @master or @main, right? Instead of just spinning.
Yeah.
One side or the other will make it more secure, but much less manageable.
Yeah.
Right? So what do you see? Like, where the trends are going, in your opinion?
Yeah. Okay. I think there's a floor, for certain things. So I think one of the things in my presentation as an example of a floor is don't reuse your long-lived credentials that you stuck in your pipeline. Right? That's not going to affect developer productivity. It's not going to, it's just bad practice. Right? So I think that place, I think we've agreed. But I also think that what the floor is not so clear to the community. So I don't think that when I talk to developers about CICD, they don't really think about this stuff in the course of it, because it's all just oh, how do I get this to work? What do I need to put in? How do I get it to work? Blah, 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 and it works and you're happy, right? And you kind of walk away. So I think that what at least I see is that there's not in the community now a sense for these are things we absolutely must do. And I think you're almost one level ahead of where we are, which is okay, do we set it like this or do we set it like that? One is more secure, one is less secure. I really think if you walk away from this to just thinking next time you touch your pipeline, not just to make sure it worked, but to also think about, well, what credential did I just put in? And how does this credential interact with everything else? Was that the right credential, right? Or could I scope this credential? Nobody's going to notice if I scope this credential in the pipeline, probably, right? Did I think about that before I walked away? And I would say that most people don't necessarily think about that, so I think that's where the floor is. The rest, I think, is organization by organization. Same way if you look at websites today, you've got some websites the login cookie lasts for a month, you've got some websites the login cookie lasts for a day, so I really think it depends on the application and where you're working. So I think the message that I have for the community is just when you're interacting with the pipeline, it's not just about making the pipeline work, but it's also just thinking what did you just add? And who can touch this? And how much of this did I really need? Because I'm the person who set up the pipeline, right? I should be thinking about this at the moment I'm setting up the pipeline. So that's kind of my way of sneaking out of answering your question, but I do think that's a good way to kind of think about things.
Thank you very much.
Thank you.